All right, so part two, right? Part two. Let's do a quick review, and then we'll get rolling on. Okay, so everything starts with the remainder theorem. So the remainder theorem is the beginning of it all. What basically is the remainder theorem saying? It's simply saying this: you take a factor and look at the value, and technically, if you set this thing equal to 0 and solve it, right, you're going to get a value of the variable. In this case, 2. If you stick that 2 in for the independent variable, the function, go ahead and solve it. You'll figure out the remainder as if you took this, look back over here on the right, this binomial, and divided it into the polynomial. And again, I did the proof here over on the right-hand side as we did it long division. So in this case, we got a 0 remainder from placing the value of x in, and we got a 0 remainder when you went ahead and did long division, right? Same thing here, second example. Again, if you would set this equal to 0 and solve, we're going to put a -1 in there. When you run a -1, using the remainder theorem, we got 8. That's the easier way to go. Long division, when we did that, same remainder, right? We got 8. So both those same concepts, and that was the remainder theorem. Then that led us to the factor theorem. And this is what we're going to use. And the factor theorem basically says is that if you get a 0 remainder, then that binomial is a factor. And that's what we want. That's what we're after. This is what we're looking for. And so we did a couple examples there. First case, putting in 3 for the independent variable. We got a 0 remainder, meaning that, yes, x minus 3 is a factor of that polynomial. And then the second time, we put in -3 for the x plus 3 factor. And in that case, we got a remainder. We didn't get 0, and therefore it's not a factor. Okay, all of that is to lead us to be able to factor polynomials. So now we've got another one. So number 3, this is called the integral root theorem. Don't get caught up on the name. I'm not going to ask you it much, so don't freak out with the term there, the integral root theorem. Basically, the key to this is it's used to find the possible binomial factors. So let me try to explain. If you look back up here at the factor theorem, right? What were we doing with the factor theorem? They gave us a binomial, right? And said, is it a factor? And they gave us a binomial and said, is it a factor? Okay, great. That's great when they give you the binomial. But when you're told to solve a polynomial equation or a polynomial function, they don't give you any factors. They don't say, is this a factor of it? You have to come up with them. You have to decide which binomials you're going to use. And if you have no direction, there is an infinite number of binomials, right? Not good. So what do I try? What do I use? Do I just pull things out of the air? What do I do? And the integral root theorem is really designed to keep us from just pulling things out of the air and helping us out. All right, so let me use my shade here so you focus where I need you to focus. Okay, so you look at this right now, and I know that looks like a lot, and you're looking at this thing and saying, what in the world is that? All right, don't worry about it. It's not a big deal. It's just a progression. And what it's trying to show you is a possible polynomial. A sub n is simply the 5, the coefficient of the lead term. Don't worry about it. It's not a big deal. So in this case, n is 5, right? And you got x to the 5th. Okay. And then this would be the next lowest term, right? The 4th term. And now this is 2 lower than the original, or 1 lower than the previous, right? And now you're down to 3rd. And you'd go down to 2nd, and you'd go down to 1st. And then when you're all done with all the coefficients and variables, you would finally get down to a constant, and we're going to call that a sub 0. So write that in. And this is what we're after. This is what we want. A sub 0. So on the bottom example, I didn't finish off with what the a sub 0 is, but in this case, I'm going to stick if I can ever get the pen I want. All right, come on. All right, so in this one, we're going to stick a 7. And it is this 7 that we're after. So in this case, a sub 0 is 7. It's simply the number. So if you don't understand all of this, it really doesn't matter. It's just giving you a pattern for the polynomial. If you don't understand that, it really doesn't matter as long as you understand we're looking at the number at the end. Just a pure number, no variable associated with it. That's all we really care about. That's what we're after. So if you fill in the next blank, so any integral root will be a factor of the, and that's a to the 0 term, or a sub 0 term. And basically, what are we talking about? We're talking about the constant, the number. That's what we're after. Okay, so again, why are we doing this? We're doing this because we need to figure out the possible factors for any polynomial. We've got to find possible factors. And it's not the kind of thing where we can do trial and error and stuff like that. It'd take you forever. So we're looking for possible factors. That's what we're after. That's the whole key. So if you look at this first example here, a sub 0 is the 6, right? Would you agree? I hope you would. So here are the possibilities, right? You could have an x plus 1 factor and an x plus 6 factor. Doesn't a 1 times 6 give you a 6? That's why I chose the 1 and the 6. 1 times 6 is 6. You could have a negative 1 and a negative 6, right? Just think about multiplying out binomials, and don't you end up with the last term being a positive 6? You do. So then what are some of the other possibilities? There's 4 more. Go ahead and say it. Right? So 2 and 3, x plus 2, x plus 3, right, gets you a 6. And that leaves us the last possibility, x negative 2, x negative 3. Okay, so now really in this polynomial, there are 8 possible polynomial factors that might be, binomial factors that might be a factor of that polynomial. And we won't know until we use the factor theorem, right? We figure out if the remainder is 0. If the remainder is 0, hey, it works and we're good and we're happy and everything's nice and everything's grand. So we will use these possible factors in conjunction with the factor theorem to find a factor of the polynomial. That's what we're after. Okay, so I got 2 examples there for you, right? I'm going to put this higher for my sake. Okay, so out of those factors that we tried, so here's the x minus 1, right? And we're going to try it. So again, we're putting a 1 in, right? Because x minus 1 equals 0 and x is a 1, right? So there goes the 1 in for the independent variable. And so let's sub in 1 every place where the independent variable is. Because again, we're trying to find out, does it equal 0? Does this equal 0? Okay, 1 cubed is 1. 1 squared is 1 times a negative 2 is a negative 2. 5 times 1 is negative 5 plus 6. And lo and behold, it does equal 0. And this is a yes. Now I knew it was going to work, and that's why I chose it. Not all of them will work. The second one will also work because I chose it for that reason. And so on this one, again, if you take the binomial, solve it for, set it equal to 0 and solve it, we're putting a -2 in. And again, a lot of you guys don't need to do that step. You understand if you're testing an x plus 2 binomial, you know to put in -2 for the variable, right? So you don't really need to do that step. You know what to do. All right, so go ahead and sub in a -2 everywhere where you see the variable and see if you end up with 0. Be careful with your positives and negatives. Go ahead and sub in. See where you end. Okay, so hopefully you said -2 cubed. -2 times -2 is 4. -2 times +4 is a -8, right? Second one, -2 squared is 4. -2 times 4 is a -8. -5 times a -2 is a +10 plus 16, and sure enough, -16 and -16 equals 0, and this again is a yes. So in this case, there were 2 factors. There might be a third. There might be more. If you guys look at this thing, this is a 3rd degree, right? So at most, you're going to have 3 binomial factors at most. So we found 2 of them work, right? The x plus 2 works. The x minus 1 works. There might be a third. There might be only 2 for a 3rd degree polynomial. There might be only 1 for a 3rd degree polynomial. In actuality, there's a possibility there might not be any binomial factors, at least not any with integers. And so you just have to try and figure it out. All right, any questions so far on the integral root theorem? Remember, all of this is so that we can factor polynomials. So we got to find a factor. That's what we're after. We need the factors. And so we'll use the remainder theorem in conjunction with the factor theorem. And the integral root theorem will help us to figure out what binomials to try. And from that, we'll be able to factor. It's a big deal, isn't it? A lot of work. Hence 2 days to do it. All right, let's go on. No questions. Oh, so all of that was there. That's fine. I did it back in my review area. Not a problem. All right, see if we can get that to go away. All right, so number 4. So polynomial equations can be solved by setting them equal to 0 and factoring. Just like quadratics, right? How do we solve quadratics? We set them equal to 0 and we factored. We're going to do the same thing with polynomial equations. Okay, so step 1, I set it equal to 0, right? So I move the 6 to the other side by adding a -6 to both sides, right? And set the thing equal to 0. Now comes the integral root theorem. So, and that's right here. So why don't you go through and list what you think are the possible factors. Go ahead and list out. You should end up with 2, 4. Well, you know what? This one's boring. Let's just do it because it's another -6 and it's close to the same thing, right? Like how about -1 times +6, right? Or +1 and -6, right? Or -2 and +3. And the last possibility is +2 and -3, right? We have all of those possibilities. Okay, so those of you that are living blessed lives, everything's working well for you. Out of those 8 possibilities, you might pick one that works on the first try. All right, that just might be the case for you. Everything's going well, you're good to go, and you're going to pick one that works on the first try. So let's just see what happens. Who wants to give me a binomial to try? Don't run them through your head. Just pick at random a binomial to try. Anybody? All right, Noah, give me a binomial. The x minus 2. All right, so Noah wants to try the x minus 2. So that means we're going to use x equals 2, right? Again, if it's an x minus 2 polynomial, we're going to use x equals 2. So let's go ahead and run it. Again, you're just taking your binomial, and everywhere where the variable is, you're sticking in 2. This is our first try. Maybe our last. If Noah's good to go. All right, so I just took this binomial up here, right? And everywhere where the variable was, I put in 2, and I'm hoping to get 0. All right, Noah, 2 cubed is 8. A negative 3 times a 2 squared is a negative 12, plus a 22 minus 6. So we have 30 and negative 18. Ah, Noah. Sorry, man. That one's out. All right, we did not get it on the first try. All right, that's the way it goes. All right, let's try someone else. Who else wants to give me a binomial? Amma. Say it again. X minus 1, Amma. Let's try that. X minus 1. All right, we'll try that one on the second try. I like that. So our second try is x minus 1. So again, what are we going to use? We're going to use x equals 1, right? So let's go through and sub in a 1 everywhere where you see the variable. All right, so we're just taking that original, right here. We're subbing in 1. 1 cubed is 1. Negative 3 times 1 squared is negative 3. 11 times 1 is 11. Minus 6. Oh, that did not work. That's not good. What in the world? All right, that's bad. Oh, this is bad. Oh, no, I don't like that. This is very, very bad. Dun, 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 dun. Dun, 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 dun. All right, we have to make a change. That's what happens with things at times. All right, go back. Take a red and make this a negative 6 because we're going to be in trouble if we don't do this. So just go back to your original, make that a negative 6. Therefore, then when we put it on the other side, it's going to be a positive 6. All right, little mistake transposing there. So, okay, let's go back and look at the first possibility then, making that a plus 6 and that a plus 6. By the way, all these factors will still end up the same in the long run. You would have just did a positive 1, positive 6, but right underneath would have been a negative 1, negative 6, and you'd still get all the factors. Okay, so this one would have been, that would have been a 6, and that still would not have worked, right? You'd have had 8 minus 12 plus 22 plus 6, and that would have been out. All right, what happens here? I'm still not liking it, are you? 17 and 4. What a mess. All right. I don't know what I did here, but somehow I did an example that is no good. All right, you know what? Let's just stop and say let's not fool with it the rest of the way. We'll do the last example, and that one will work, and we'll show you what to do. All right, so it's not worth it. Let's just go on to the next one. Otherwise, it's just going to make things more confusing. Okay, so let me try to get your focus back after that mistake. So here's the situation on this one. Now, instead of it being an equation, it's a function, polynomial function. Okay, so a little bit different. The only difference is there's a y there instead of it being set equal to 0. So the procedure is the same. Solving a polynomial equation is the exact same thing as finding the zeros of a polynomial function. Solving a polynomial equation is the exact same thing as finding the zeros of a polynomial function. And this is what we want, because down the road we're going to end up graphing these things. And the zeros are the key things to graphing it. All right, so this procedure solves an equation. Again, you'd set it equal to 0 or solve, or it finds the zeros of a function if you set it equal to 0 and solve. And so that's what we're going to do on this one. So set it equal to 0. Piece of cake, right? We're just going to stick a 0 in where the y is. And we have equals 2x cubed minus 3x squared minus 23x plus 12. Okay, so that was step 1. Step 2 now, we've got to find these possible factors. And a 12 gives you a good amount of them. Okay, so what are all the possibilities here with a 12, right? The integral root theorem, the constant, the number without a variable associated with it. Okay, positive 1, positive 12, right? I like to be orderly. You can be random, but if you're random, then you got to make sure you didn't miss something. And you're not always going to know, okay, there's 2, 4, 6, 8, 10, 12 of them. You're not always going to know that. So negative 1, negative 12, positive 2, positive 6, negative 2, negative 6, positive 3, positive 4, negative 3, negative 4, right? Those are the possibilities there, and that's what we're looking at. And hopefully, I hope, this one's going to work out well. We will see. We will see. We will see. All right, so let's go back again. Now we got to find the factor, right? And so we got to start trying one of these 12. So, Raina, pick a factor, any factor. Okay, so you want the x plus 3? Okay. All right, so we're going to try the x plus 3 factor. So that implies we're going to use x equals negative 3, right? Again, if you can't do that in your head, set the x plus 3 equal to 0 and solve the little equation. Okay, so we are after a 0, so everywhere where the variable is, I'm putting in negative 3. All right, so everywhere where the variable is, you are putting in negative 3. All right, just be careful with your exponents. Use your calculator if you need to. Write the first term, a negative 3 cubed. Negative 3 times negative 3 is 9, times negative 3 is a negative 27, right, in the front. The second term, a negative 3 squared is a 9. A negative 3 times a 9 is a negative 27. The next term is what? A positive 69 and a 12. So what's 2 times negative 27? Is that what, a negative 54? So what do we got? A negative 81 and a positive 81. All right, first try, Raina. Awesome. Okay, there were 12 possibilities. Maybe as many as 3 work. Maybe. Maybe as many as 3 work. And out of those 12, she found one that works. Now, maybe only 2 work, maybe only 1 works, but we did find one. What happens if it didn't work? Now, again, you got to go to another one, try another one. Sometimes you can look at what you get as a remainder and say, hey, I was close. Like in this one, you used x plus 3, so we used an x equal negative 3. If we were close, I may try the x plus 4 so that I use a negative 4 if I'm close. Doesn't always work, but it can kind of help you a little bit down the road. All right, so that's step 1. All right, really step 2. All right, so now what's next? Uh-oh, we know a factor. Woohoo! Well, at this point, here's what some students try to do. They say, hey, I like the factor theorem. It's cool. I'm just going to keep trying the rest of these factors to find any more factors. Well, if you do that and none of these are factors, now you've just wasted all that time. So you don't want to do that. So the next step is, now that you found a factor, use long division. Dawson doesn't like that long division. Come on, Dawson, you've been doing it since elementary. It's not that bad. All right, so what are we doing? We got a 2x cubed minus a 3x squared minus a 23x plus a 12, right? We know this factor is going to give us a 0 remainder. We know that. So we know it's a factor, so we got to do long division. Okay. First divided by first, right? 2x cubed divided by an x is a 2x squared. Put it in the x squared column, right? You remember? Now multiply x times 2x squared, 2x cubed. Positive 3 times 2x squared is a positive 6x squared, right? And remember, this is long division, so you got to subtract. So now we have what, a negative 9x squared? Right, distributing that negative. Bring down the negative 23x. And again, first divided by first. Negative 9x squared divided by x, that's easy, right? That's a negative 9x. So again, now distribute the x times the negative 9x is negative 9x squared. Positive 3 times the negative 9x, negative 27x. And don't forget, you're subtracting, right? Long division. Now we have what, a 4x? Because again, you're distributing that negative, right? Bring down your 12. Again, first divided by first. 4x divided by x is a positive 4. X times 4 is a 4x. Positive 3 times 4 is a positive 12. And you're subtracting, and hey, 0. Great. It's what we wanted. We wanted a 0. We got a 0. We're good. I need more space, and I need to go higher. So at this point, what's next? Factor the dividend. So look, let me show you where we're at right now. This is where we're at. The divisor, x plus 3, is a factor of that polynomial. And we also have a 2x squared minus 9x plus 4, right? From here. Remember, in division, this times that always equals the original, right? Yes? We have life there. All right, just to make sure, because you're getting me scared. If you divide it 2 into 12, you would say 2 goes into 12, 6 times 12, remainder 0, and a 2 times a 6 is a 12, right? All right, so I'm sure you were good, but you scared me there. Okay, so what we want to do now is we want to look to see if we can factor this trinomial. And we know how to do that. Trial and error. So I'm not going to lose my x plus 3, but I'm going to factor my trinomial. So you know the fronts have to be a 2x and an x, right? We've done factoring before. All right, and we got a positive 4 with a negative in the middle. So you know you got to use a negative times a negative, right? It's the only way you're going to get to a positive 4. Anybody see the factoring? Remember, you're looking to get a negative 9x in the middle. Alex, what do you think? Negative 1, negative 4, right? If you look at this, if you're thinking of the check, 2x times a negative 4 is a negative 8x. Negative 1 times x is one more negative for the middle term of negative 9x, right? And that's what we wanted. Okay. So these are our 3 factors. An x plus 3, a 2x minus 1, and an x minus 4. Now let me pause before we finish. And let's look back up here at this list. So Raina said, let's use the x plus 3. What else have we found from the list? What was it? An x minus 4. So this one worked as well, and that was it. Only 2 of those 12 would have worked. Okay, so here's what students do. All right, students, find the zeros. Okay. And you go through and say, oh, yes, integral root theorem. Let's see, there are these factors. Now, some students don't bother to list all the factors because they're lazy. But they don't bother to do that. And so you know what they do? They try a factor. It doesn't work. Oh. And they try a second factor, and it doesn't work. And you know what they do after that? What do you think they do? What do you think they write on their paper? I'm stuck. I'm stuck. Okay, and therefore then they just wasted their time that night and really didn't learn what they need to learn, and because they didn't persevere. And look, in this one, we could have tried 10 factors before hitting a factor that worked, because only 2 of the 12 worked. You just got to hang in there and keep working at factors. In most cases, almost all, the ones we give you, at least one of the factors is going to work. And in most cases, maybe 2 or 3 of them. Okay? So you just got to hang in there. You got to keep working. Okay, we're not done though, right? What was the original question? Find the zeros. Zeros are found when you set the function equal to 0. You find the factors, and then remember, to finish, you set each of those factors equal to 0. So I want to use my red here. So you set each of those factors equal to 0, right? This is going to give us the zeros. Now, by the way, the zeros would also be the solution to a polynomial equation, right? The values of the variable that would solve the equation if it weren't a function. So here, this one's x equal -3. I think we're at the point where we can do the second one in our head, right? You get what? X equals 1/2. And the third one, you get x equals 4. Isn't that amazing? All of that to be able to do that. All right, don't put this in your notes, but let me just try to show you where we're going. So if we were asked to graph this polynomial, we'd have done everything we just did. Again, don't put this in your notes. We would then set up a Cartesian plane. We would graph the 0 of x equal -3. We would graph the 0 of x equal 1/2. And we would graph the 0 of x equal 4. And so now we have these 3 zeros. And we'd have to figure out the rest of the function. And we're going to talk about this the next couple days. But because of what this function is, right, a 2x cubed minus 3x squared minus 23x plus 12, I can tell you this. We'll do a little bit more to figure out exactly where it goes, but I know this thing goes something like this. And you'll figure that out after tomorrow as well. But these zeros are the key to everything, and that's why we got to find them, and that's what we're doing. Okay? So remember, finding the zeros of a polynomial function is exactly the same thing as solving a polynomial equation. If you were solving a polynomial equation, you'd say x equal -3, x equal 1/2, x equal 4. If it's a function, those are the zeros. So let's recap. Okay, way back here. So the remainder theorem will tell you the remainder. Look, if you got homework tonight and it says, what's the remainder? You're just using the remainder theorem. Set the binomial equal to 0 and find the value to put in for the independent variable and see what you get for a remainder. Don't do long division. Use the remainder theorem. That's all you're after. If they say to you, is this binomial a factor? Just use the factor theorem and see if you get 0 for a remainder. Don't do long division, right? Just use the factor theorem and see if you get 0 for a remainder. If it is, then it's a factor. If they say solve the polynomial equation, hope that they gave you one that works, and hopefully they will. Use the integral root theorem to list out your possible factors, and then start trying to find one that gives you a 0 remainder. When you get it, do long division, set those factors equal to 0, and then you'll get the solution. By the way, what would happen, let me go to this last one. All right, so think for a second. We're right here, right? We go to factor this trinomial. What if that trinomial didn't factor? And it's a polynomial equation, or we're looking for all the zeros. What happens if that trinomial doesn't factor? What would you do? You all know. What would you do? Meredith? You would use the quadratic equation, right? X equals negative b plus or minus square root of b squared minus 4ac all over 2a, right, Shane? Yeah, right? Quadratic equation. Don't write, I'm stuck at that point. Oh, there's only 1 0, I'm stuck. No, you'd have to use the quadratic equation and finish the thing off with the quadratic equation. This one factored, and it was nice, and we can get all the way to the zeros. All right? Got it? Great, great.